Hello everyone, welcome to the advanced scanning module of the course. Now before we actually get started with performing any advanced scans and understanding port scanning, we are going to be setting up two virtual machines that contain our two vulnerable operating systems that have a list of all of very important services. Now the reason we're doing this is because we want some diversity when it comes down to the targets that we're going to be scanning, just so I can demonstrate some of the the really important scanning features that are operating system nuanced. So again, I'll be talking about Linux scanning and Windows specific scanning. So the two targets that I'm going to be using in this course, and they're very easy to set up and are absolutely free to utilize, are going to be Metasploitable 2, which is an intentionally vulnerable virtual machine that can be set up on VMware or VirtualBox. And again, Metasploitable 2 is already is a Linux box, and then we have Metasploitable 3. This is a Windows box, and it's based off Windows Server 2008. The only difference is that Metasploitable 2 already comes as an OVA file, which means you just need to click on it if you have VirtualBox installed, and it'll automatically set it up for you. With Metasploitable 3, you need to perform the build process, and the reason you need to do that is because it utilizes the free Windows Server 2008 evaluation trial, and to do that it needs to pull the ISO file manually. So the install process is very simple. If you're on Windows, you can run the PowerShell script, and if you're on Linux, you can run the build bash or shell script right over here, and it gives you instructions on how to do this. All the links to these resources or to these two boxes will be in the resources section of this video, so you can access them that way. If you have any trouble setting up and building Metasploitable 3, you can follow our build guide on hackersploit.org under Metasploitable 3 installation guide. It is a comprehensive guide with a free video tutorial. You can also check out the rest of our free video tutorials on our YouTube channel if you want more guides on how to set up Metasploitable 3. So again, Metasploitable 3 requires VirtualBox and Vagrant. It requires VirtualBox, Vagrant, and Packer. And again, you can actually run this on QEMU or KVM on Linux, or the virtual machine manager. That's if you're running on Linux, and you also have the ability to run it in VMware Pro. So again, it's entirely up to you. I personally recommend VirtualBox. That's what I've been using, and it's been working just fine. And again, as I said, this is based on Windows Server 2008. So again, you can follow all the installation instructions, and I'll post as many resources as I can regarding setting them up. So what I have here are the two files. So again, I personally set up my own OVF file for Metasploitable 3, and the Metasploitable 2 archive is a simple VMDK file. So it already is installed, and all you need to do is you just create a new virtual machine. So I'll just extract this, and we'll give that a few seconds just to complete the extraction process. I already have Metasploitable 2 and Metasploitable 3 set up, so I'm already ready to go. So I'll just wait for this to complete extracting, and I'll show you how you can set this up. With an OVF file, all you need to do is double click on it, and it'll essentially start up the wizard with VirtualBox to start the importation process. So with Metasploitable 2, you can see that it provides you with a virtual machine disk file. So if I click on that, you can see, because I already have Metasploitable 2 set up, I don't need to do it again. But again, you just need to click on the VMDK file, or to create a new virtual machine and specify the VMDK file as the actual disk. All right. So once you have that set up, I'm just going to delete that. We can then start up the virtual machines. So I already have my Kali box running. I'm just going to start up, let me just close one of these instances. I'm going to start up Metasploitable 2, and I'm just going to show you how that works. All right. So by the way, before you do that, you want to make sure that your network settings are set to bridged, and you want to go to network, and you're looking for your bridged adapter, and you want to make sure they are on your current Ethernet or wireless network interface, right? And you also want to do that for Metasploitable 3. So I'll also make sure that that is done. So this is bridged, and I'm going to start up Metasploitable 2. So this is our Linux box, right, that we're going to be using in our virtual lab. So that is started up. We'll give that a few seconds to start up, and I'll just take you through the actual login process. And All right, so once the startup is complete, you have the default credentials. You can log in with MSF admin and the password of MSF admin to get started. So again, you can simply type in MSF admin for the username, MSF admin for the password, and there we are. And again, you can check the interface IP just to make sure it's on your local network. And there we are, it's 192.168.1.121. All right, so that is our, so I'm just going to shut down this box now. So that is our Linux box. We then have Metasploitable 3, which is Windows Server 2008. So I'm just going to start that up and I'll show you how to log in and how everything is configured and how we'll be using the Windows firewall to perform scans. And when we start talking about firewall bypass, we'll also be covering that as well. So again, you can set this up if you want. If not, you can also use your default Windows installation. That could be Windows 10, Windows 7. It really doesn't matter as your target, but I would recommend setting up Metasploitable 3 mainly because it has tons of services that will be scanning. So you want to look for input, and I'm just going to insert Control Alt and Delete, and we want to log in as Vagrant, and the password is going to be Vagrant. Just going to hit enter. And you can see it's Windows Server 2008 R2. So we're just going to give that a few seconds to prepare our desktop, and you can then begin configuring the various services that you want and configuring the firewall based on what you want to test specifically. But with Metasploitable 3, I would recommend keeping the basics as they are. So it already comes pre-configured with vulnerable services. So again, if I type in my IP here, so IP config, you can see it's on our local network under the IP 192.168.1.38. Excellent. And then you can access your Windows firewall right over here. All right, so we'll give that a few seconds to load up. All right, so the Windows firewall is right over here. And again, you can enable or disable it. And this is very important because we'll be doing both, right? And the reason we'll be doing both is because I'll actually demonstrate and show you the differences. So you can see it's currently disabled by default, and you want to leave it that way. When after you've installed or completed the build process for Metasploitable, you want to disable that. And then of course you have your inbound and outbound rules, and by default the following ports will be actually closed here. So you can actually see that we have closed port for NetBIOS, MySQL, remote desktop access, and SMB. And I just added a test here, which I will just get rid of. And there we are. So those are our firewall rules. You want to leave the firewall disabled. And there we are. So now that we have our virtual lab set up, I'm just going to shut the machine down. And we can now get started with our advanced port scanning section and, enumeration, taking a look at Nmap scripts, so on and so forth. So again, I'll just turn this off, and we'll just change the reason to other, and I'll just say shutdown. There we are, and I'm just going to shut that down. And once we're ready to begin, we are now going to be running both of these virtual machines simultaneously. You can allocate as much resources as you currently have on your computer, and you can run them one by one based on the types of scans we'll be performing. As I said, we'll be performing Linux scans and then Windows-based scans, and I'll be showing you the differences, especially when it comes down to enumeration with Nmap scripts. All right, so that's going to be it for this video, and I'll be seeing you in the next video. Hello everyone, welcome to this video. In this video, we're going to be talking about the default Nmap scan. We'll also touch on the port states. However, that will also be explained as we proceed throughout the course. But let's get started with the default Nmap scan so that we understand what Nmap is doing by default, right? So a default Nmap scan, as the name suggests, is a scan that you run without specifying any options or arguments, right? And this is a default scan that will be performed if you don't provide any arguments or options regarding what you want to do exactly. So again, this is done by typing in Nmap and then typing in your target, which could be a URL, and you can perform your reverse DNS resolution by using the R command, or you can provide the IP. In our case, we can the default Nmap scan will perform reverse DNS resolution for us. Let's start off by scanning the scanme.org website, right? So nmap.scanme.org, and we want to hit enter. So this is a default scan. Now there's a few important things about a default scan which we'll touch upon in a bit. So let's wait for this scan to complete. Now we are going to be using the other virtual machines that we set up, which is Metasploitable 2 and Metasploitable 3 as we move along, as we start talking about operating specific scans which do exist, and we'll talk about enumerating various services through the use of Nmap scripts. But for now, let's just talk about ports, right? Because that's very important right now. We've talked about host discovery, which is discovering in the devices that are online. Now let's talk about discovering ports on these devices. All right, so you can see that the default scan returns a few important bits of information. The most important bit here is it'll tell us that 996 ports are filtered. Now let me explain something. The default Nmap scan will scan for 1000 of the most commonly used ports, right? It will not scan the entire range of 65,535. You can specify that, and that's exactly what we'll be taking a look at in the next video. But the default scan only scans 1000 of the most common ports, right? So again, it tells us here that 996 ports are filtered. I'll explain what the port states are in a second. So we can see the default scan performs reverse DNS resolution and gives us the IP address for that particular domain. Apart from that, again, we get the IPv6 address, but that's really all it does. Now, you can see the ports that are open and the various services running on these ports, which, you know, is expected to be standard. We currently only have 4 ports that are currently open out of the 1000 that was scanned. I'm sure if we specify the entire port range, we'll be able to discover a whole lot more. So what we can see is that the results for the port scan are sorted out into 3 columns, right? So we have the port, which specifies the port number or displays the port number, and the protocol. In this case, it's TCP. When we perform a UDP scan, it will tell us that this is a UDP port. We then have the state of the port, which is either open, closed, filtered, etc. I'll get to that in a few seconds. And then we have the service that is running. So the service could be SSH, HTTP, etc., etc. And again, when we perform service version scanning, it will also display the version numbers, which you can then use for vulnerability scanning or vulnerability analysis, right? So right now, let's talk about the port states, which is very, very important, right? So your port states give you information regarding the port and what current state it's in. So when a port is open, what this indicates is that the service is open and is listening for active incoming connections, right? So that means you can interact with that particular port, right? It doesn't mean that the port is open to be accessed by anyone, in that you can authenticate it without you can authenticate to it without a password. It just means you can access it on that particular port, right? So for example, for port 80, we can see that this is a web server and the port is open. So if we go into our browser here and we type in the nmap.scanme.org.scanme.org, let's see if we get any results. So there we are. It takes us to this URL right over here, which indeed proves the fact that this port is open. And again, if we try and access SSH, it'll also work as well. So that's the open port. That is the open state for ports. Let's talk about closed, right? So if the state of a port is closed, this will essentially say, this essentially means that all the requests that we sent were received, but Nmap came to the conclusion, based on the responses we got back, or based on the responses that Nmap got back, that that port is closed, right, and is not accepting any connections, and there isn't any service running on it. All right. You then have the filtered state, right? So the filtered state is very important. The filtered state, as we'll take a look at when we're scanning Windows devices, actually indicates or will prove that there is some sort of packet filtering or a firewall that is blocking your scans from being completed, right? Or Nmap was able to come to the conclusion that there is packet filtering because again, there is no indication from the device, so it did not respond back or give us any feedback that Nmap could use to come to a conclusion as to whether the port is open or closed, and that means that it's filtered, right? So the packets are being filtered as they're incoming and outgoing, and that may indicate that there is a firewall in place. And in this case, you can see that it tells us for the rest of the 996 ports, those are all filtered. Now we'll talk about filtered ports when we'll be taking a look at firewalls and how to detect them and how to evade them. Let's take a look at some other port states, which are going to be the open filtered ports, right? So your open filtered ports essentially prove that, again, the port is active and open but again, an Nmap could not establish a connection or a state with that particular port. If it's closed, again, it means that the port is filtered or is being filtered, and the state could not be established. So those are your port states. Now that we understand a default Nmap scan and how the port scan results are displayed, we'll now take a look at the various port scanning options and the port ranges that you can specify when you're talking about port specific scans. So I'll be seeing you in the next video. Hello everyone, in this video I'm going to be talking about performing the fast scan with Nmap. The fast scan with Nmap is a really simple scan to understand. All you're doing is you're scanning for the top 100 most common ports, as opposed to your default scan, which scans for the top 1000 most common ports. So again, you're reducing the amount of ports you're scanning to the top 100 most common ports, and this of course is much faster. So one of the reasons you might want to use this is when you simply just want to have an overview of the 100 most common ports that are currently running on this device, and those range from FTP, SSH, HTTP, HTTPS, etc. So again, running it is very simple. We simply type in Nmap and we use the capital F, so minus capital F option, and then we specify the target. In this case, it's going to be 192.168.1. Let's see, 0.38. Let's run it on the Windows device, and I hit enter, or the Metasploitable 2 device, sorry, and you can see it'll tell us the host is up, and then we say not shown 86 closed ports. Again, that tells us the same thing. So 14 ports are open out of the 186 of them are closed. So again, it gives us a summary here. So you can see it gives us port 21, 22, 80, 135, 139, 445, 3306, which is MySQL, so on and so forth. So again, it's very comprehensive in regards to the types of protocols and services it is scanning for. These are very, very important or critical protocols. So again, this scan is entirely up to you based on when you feel you want to use it. Again, as I said, it's scanning for the 100 most common ports. And again, you can use this in conjunction with any of the other scan options that you have available to you, like service version detection. So again, I can run the fast scan option with service version detection, and we'll just wait for this to complete. Given that we're now performing scans for the service version versions, that will take it'll take a few more seconds. Or even up to a minute, but given that this is scanning for 100 ports, it shouldn't take too much time. So we're just going to let that complete the scan. All right, so the scan is complete, and that took about 1 minute and a few seconds. So again, 83.18 seconds, and there we are. It performed the scan on the 100 most common ports, and it gave us the service version detection for each of them. So again, you can use the fast scan whenever you feel you need to get like an overview of what services are running on it. And again, if you're looking for the 100 most common ones, this is the scan for you. But of course, you can also specify that with your port range. So it's entirely up to you based on when you feel it's appropriate to use. That being said, that's going to be it for this video, and I'll be seeing you in the next video. Hello everyone, and welcome. In this video, we're going to be taking a look at output and logging and verbosity with Nmap. All right, so we have taken a look at a lot of different types of scans, and as we've been able to tell so far, we've been able to gather a lot of information from our targets and from our network. Now, one of the most important aspects of penetration testing is documentation, and for good reason, because at the end of every penetration test you need to generate a report, and you need to again cite various sources in your report, to actually prove that you were able to find information, how you came to various conclusions, how you made decisions based on what results, etc., etc. So it comes as no surprise that documenting each stage of your penetration test, even network scanning with Nmap, is extremely important, not just for documentation and report generation, but for your own sake. And the fact that you need to go back to results every now and then just to check for various services or anything you might have missed. And Nmap is no exception to how great a tool can be in regards to how you can output information. So with Nmap, you can output information into various formats, and after that, I'm just going to talk about verbosity after that, because verbosity has to do with the amount of information that is being displayed to the user through the terminal. It's not referring to the amount of information that will be stored in the file. So if we open up the man pages for Nmap, right, and we want to scroll all the way right to the bottom here, and we have the output options, right? So the output options are sorted in terms of we have three major output options with Nmap, or output formats. We have the normal format, which is text that a normal user can read, and you can store this in a TXT file or any human readable file format. You then have the OX option, which is XML, which again you can use to parse onto a web page, or to output onto any other interface that you would like to use. You then have the OG format, which is the greppable format, which is great for it's a fantastic file format that again is primarily used when you want to utilize it with a utility like grep. So that's why it's called the greppable format, right? And you have the ability to output them individually using the options here, or you can output all three of them and specify the file name, and it'll output that for you. So that's truly fantastic. Now, when you talk about verbosity, verbosity is simply referring to the information that is displayed to the user during the scan. It's not referring to the actual scan results. When we talk about output and the output options, that is referring to the scan results and how to output them into a file that can be saved or archived for later use. When you talk about verbosity, that just gives the user information about what's going on during the scan. And we have about 3 levels of verbosity, and they're all denoted by V, a single V, a double V, or a triple V, right? So we can actually do that right now. So what I'm going to do is we'll run a simple scan here. So we'll say Nmap, and we'll run a stealth scan, and we will perform an aggressive scan as well. And we want to make this a fast scan, right? So we just want to keep it to the 100 of the most common ports. And we can now specify the IP. So right, so we'll perform the scan on our Metasploitable 3 box, or our Windows box, and now we can output it. So we can output it into individually into their own formats, and in our case, let's output into all 3 formats. So we specify a name. So I'll just call it Win2K8, right? Just to keep things simple. The file name is going to be Win2K8. And I'm going to hit enter, right? So it's going to perform the scan, and it's going to output all the options, all the results into the file Win2K8. And then given the fact that we're outputting it into all 3 formats, it's going to then assign the various extensions to these files, or to the file name. So we should have 3 output files in different formats. So I'm just going to wait for this scan to complete. All right, so the scan is complete, and as usual, we get our, we get an aggressive scan, gives us all the information we want. So it performs an operating system detection. It then performs service version detection. Then finally, it uses the default Nmap scripts to enumerate tons of more information regarding the services. So we can now list the directory here. And you can now see we have three files that have been output by Nmap, and these all contains the results that we can see in front of us. And again, we can then we can use utilities to view them that based on their file types or their formats. So for GNmap, that is our greppable output format, and then we have the Nmap file, which is human readable. So if I cat the contents of the Win2K8 Nmap file, you can see that is a human readable format, and that's exactly the output that Nmap gives us through our terminal, right? We can also open it up with like a text editor. So if I open up my my home folder, and you can see the results there, and if I open up the Nmap, I can open this up with a text editor, right? And you can see that this displays the results that in a human readable format. If we try and open up the XML file, you can see we can open it up through a browser. So I'll just do that right now. And again, it displays it in XML formats, which is why I specify that you need to parse this into a web page for it to make any sense if you are trying to make it human readable. So that's your XML format. We then have the greppable Nmap format. So again, you can cat the contents or use grep to look for whatever files or results you're looking for. So for example, if I say grep and I use so we just say grep smb, and I say win2k8.gnmap and hit enter, we don't get anything there. Let's see if I change this from something like let's see, SSH, right? So I hit enter, and you can see we can then use grep to display, you know, various strings and results based on the actual expression that we want to use with grep. So again, there's tons of output you know, capabilities that you in regards to what you can do with the output formats. And we can now take a look at verbosity levels, which is very interesting, as I said. So if we run the previous scan that we just ran here, but we now include a verbosity option at the beginning, wherever, and we say a single V, that's you know, that'll only display some of the information. If we increase it to a double V and a triple V, it'll increase the amount of information regarding the scan and what's happening to the user. So if we start off with a single V, you can see it starts displaying information that was not previously available. Previously, when we ran the scan without any verbosity options, it would not give us any output. It would just wait for the scan to complete. So we can see, first of all, the first thing that Nmap does is it loads all 151 Nmap scripts, and then it starts the script pre-scanning, and then it starts initiating the Nmap Scripting Engine, right? And then it performs the ARP ping scans to, you know, to actually to perform a host discovery, and it then begins parallel DNS resolution of one host, and then it initiates the SYN stealth scan on these particular ports. After it's done that, Nmap is able to come to a conclusion that you know, after we have specified 100 ports, so these are the ports that are currently open, right, and are currently online and are available to be interacted with. And then it completes the SYN stealth scan at the bottom on 100 ports, and then it begins the service scan, which is where Nmap takes quite a bit of time, and it scans 14 services, right? So let me just terminate this scan by you know, entering Control C. And if I remove, well, we can actually keep those results. If we run the same scan and I increase the verbosity level, and you should see some more information now, and I hit enter. So now we can see a lot more information. Not too much, but you can see it starts the run level of 1 regarding the Nmap Scripting Engine, and this is something we haven't touched upon yet, but again, it displays more information to the user, more diagnostic information. And mind you that this output is not being recorded in the output file here that we have specified, right? So that is not being recorded. The only thing that's going to be recorded are the results of this particular scan. So that's verbosity level 2. What if we increase this to a triple V, right? And let's hit enter, and let's see. So again, it gives us a ton more information regarding what's happening during the scan. And for DNS resolution, for example, it tells us that one IP took 0.00 seconds, and then it gives us the various records here. And again, the service scanning is where, you know, Nmap starts taking time. So again, you get the idea. The verbosity level is just used for diagnostics when users want to know what's happening during the scan, so that they can, you know, they can make a decision based on the output they're getting as to whether to continue the scan or to stop the scan, or just to understand what exactly is going on. So again, that is verbosity. Now let's talk about outputting into the various 3 formats individually, as opposed to outputting all 3 formats, which can be a bit cumbersome to manage. So what I'll do is I'll go onto my desktop, right, and we can run the same scan here, but now instead of outputting it into all 3 formats, all 3 primary formats, we can output it into a normal file, which will be a human readable format. We can also do XML, and we can output into the greppable format, which we can as well. So in my case, I'll just use the normal output because this is human readable, and we'll just specify the file name. So we'll say win2k8, and we'll specify an extension like txt, just so that, you know, we have some consistency regarding the output. So again, we're running the same triple verbosity level, and we're just going to let that run. So what I'm going to do is I'm just going to wait for this to complete, and I'll get back to you when this is done. All right, so the scan is completed, and again, just to prove that verbosity and the output of the scan results are different, if I list the contents of my desktop and I cat the contents of the win2k8.txt file, you can see that it did not save any of the verbosity or any of the information that was displayed to us on the terminal. However, it just displays all the it just displays all of the results from that particular scan. So there we are, we get the entire scan here, and again it gives us the various scan options that we used, which is great. That's a great thing with Nmap results or the Nmap output, is you get the date and time when the scan was initiated, and if, again, based on the intensity and the of the scan and the various scan options you're specifying, you can get very little to a lot of information from your scan. That being said, that's pretty much all that I wanted to cover in this video, and I'll be seeing you in the next video. Hello everyone, welcome to this video. In this video we're going to be talking about inverse TCP flag scanning and performing scans like your Xmas scans, your fin scans, and your null scans. And the reason I'm including them all in one video is because they all deal with the same with the same overall concept, which is again using inverse TCP flags. Now the reason this is called is named inverse TCP flag scan is because you're not utilizing your typical TCP flags that have to do with the three-way handshake. Instead you're using the other TCP header flags that we had actually discussed in the networking fundamentals section or module, and those are your fin, urge, and push flags, right? Given that we are not following the methodology of the TCP three-way handshake, you might be asking yourself, well, how exactly is Nmap going to deduce whether a port is open or not, whether a host is open or a host is online or not? And the way it does this, right, is you send a packet, right, with either the fin, urge, push, or null packet sent, or when performing a null scan where it doesn't send any TCP header flag set at all. And then based on the response, Nmap is able to tell if a port is open or closed, or if a host is online or offline. And again, when you might be saying, well, what is the response we get when a port is open? So when a port is open, you'll not get any response from the target. So it's similar to a UDP scan, right? When the port is closed, you'll get an RST, because again the port is not going to be able to respond, and similar to your three-way handshake. If a port is closed, it's going to be an RST immediately, and that terminates the connection. So again, it's very simple to understand, and I'll be demonstrating this using Wireshark. All right, so before we get started, I want to explain a few things that that will answer a few questions that you might have in your head, right? So again, why would we want to use inverse TCP flag scanning? Well, number one, many of the firewalls and stateful firewalls and packet filtering software are already set up to detect the typical SYN request being sent to a particular port from the outside, or from an external network, or from a computer across the world, right? So they usually block these or drop these, right? And another way of trying to probe as to whether a port is open or closed is to use inverse TCP flags, because the firewall or the intrusion detection system is not expecting the use of inverse TCP flags. So that's one importance of using inverse TCP flagging, is that it allows you to evade security mechanisms. And again, when we talk about the TCP flags that we'll be using, we're going to be using the fin. We're going to be using the fin flag. We'll also be using the urge flag and the push flag. And then when we talk about the null scan is essentially a packet with no TCP headers, TCP header flag set at all, right? So as I said, all closed ports on the target will respond with an RST. If there's no response, it means that the port is open. Now, another important thing to take into consideration here is that you need super user privileges to perform this scan, and the important thing, the second important thing is the operating system nuances when talking about this scan, is that this scan is these types of scans are very useful against Linux or BSD operating system, as opposed to Windows operating systems, and we'll actually demonstrate that they really don't work well with Windows, and that's because Windows TCP IP stack or the stack onto which it's built upon does not actually respond to those types of packets, with inverse TCP flags set. So when we talk about the scans, we'll be running a few scans. We'll be running the Xmas scan, which I'll show you in a while. The Xmas scan is essentially a combination of the fin, urge, and push flags all set. And when we talk about the fin scan, again, that just involves sending the fin, sending a packet with the fin TCP header set, and then Xmas again, all three. And null scan does not include any TCP headers. So let's get started. Again, you can check up on these scans by accessing the man pages within the Nmap manual here. And we can find them under the service, under the scan techniques. So there we are. We have it right over here. We have the TCP null scan, the fin scan, and the Xmas scan. So we'll start with them, alphabetically. Let's start off with the null scan, right? So the null scan again does not send any TCP header flag set in the packets, right? So if we say nmap sn, right, and we can run this against a let's see, 192.168.1.121. As I said, these scans do not work well on Windows. They are practically ineffective against Windows, the Windows operating system. So if we run this scan, I'm just going to open up Wireshark here, and we'll open up Wireshark and we'll run this scan. And the reason I'm running Wireshark is I just want to explain what's happening. So from the state over here, again, because this is not a typical three-way handshake that we're establishing, we're going to get the state of open and filtered. And that's because Nmap cannot come to a concrete, it cannot make it cannot make up the decision, because again, it's inconsistent. The results can be wildly inconsistent. So again, for the most part, they're open because we did not get a response, and we can actually view this through Wireshark here. So we're just going to scroll all the way to the top. So you can see with the null scan, if you just highlight there, we have no TCP header flag set. If we click on the TCP section here, if we look for the flags, we can see they're set to none, right? If we get an RST, it means that port is closed. So in this case, port 554 is closed, port 143 is closed, port 256 is closed, 135 is closed, port 110 is closed, etc., etc. You can keep on going. So again, this is quite effective when you're trying to avoid detection. And so yeah, that is a simple null scan. Now, when talking about the other scans, like the fin scan, which is next, let me just check that one more time. I want to go through it alphabetically. So we take a look at the scan options. So it's a fin scan. Yeah, so the fin scan again is quite simple to understand. We're essentially sending a packet with the fin TCP header flag set. And again, the process is essentially the same. If we get an RST back, that port is closed. If we don't get a response, it means that port is open. So again, SF, this time 192.168.1.121, and I'll just begin the capture again here with Wireshark, and we'll hit enter, right? And we'll just wait for that to complete, and there we are. We get the same open filtered state for the ports. And if we just stop the capture now and go all the way to the top right over here, and we can see we send all the TCP packets with the fin header flag set right over here, and you can actually confirm that. And then we get multiple RSTs for the ports that are closed. So we have port 256 closed, 443 closed, and again, the ones we do not get a response from regarding so like for example port 80, we don't get a response back. That means that port is open. So again, it's fairly simple to understand how inverse TCP header flag scanning works. We're essentially just using all the other TCP header flags that are not part of the three-way handshake, and to actually perform these scans. And again, Nmap is able to come to these conclusions based on the results we get. So again, this is a great place to actually run the reason option here, just so that it's clear. So there we are. As I said, the reason that Nmap was able to come to a conclusion as to whether this port here was open is that it did not get any response, right? So that makes sense. So if I run this on a particular port, let's say, let's look for a service that does not exist here. If I say port 8080, for example, let's see, that might be open, but I'm not entirely sure. Let me just hit enter. So you can see In this case, that port 8080 is closed, and the reason it's closed is because we got an RST from the target, and that again is conclusive towards the fact that this port is closed. So that's how to perform a fin scan. Now, when we talk about an XMA scan, an XMA scan combines the fin TCP header, the urge TCP header, and the push TCP header, right, all in one, and that gives you a very, very comprehensive scan. So again, the same thing goes with the XMA scan. You're essentially just sending a packet with fin, urge, and push set. And if we don't get a response, the port is open. If we get an RST, the port is closed. And it's very important to note that this will not work on Windows. And I'll actually try this out right now. But let's talk about the advantages of an XMA scan, because it's used quite a bit. Number one, it's great for evading intrusion detection systems and firewalls, because you're avoiding the TCP three-way handshake entirely. And again, the disadvantage is quite clear. It only works on Windows, right? So that's quite clear already. So again, this can be accessed by opening up Nmap, and I'll just scroll through this quickly, and we have it under the SX option here, right? So we can do that right now. So I'm going to say Nmap, and we'll also run it against Windows here. 192.168.1. We'll say 121 first, right? And I'll start the capture again on Wireshark, just so I can capture the TCP header flags that are being sent here. And there we are. So I'll stop the capture, and we go all the way to the top, and there you are. So you can see it for yourself. We are sending the fin, push, and urge TCP header flags, and you can also confirm that by taking a look at the TCP section right over here, and it displays exactly what I had said earlier. So again, it's sending fin, push, and urge to the target, and then for the ports that are closed, we get the RSTs back here, and for the ports that we do not get a response from, those ports are pretty much open. So again, we can also run the reason option here, just to prove that again. So if a port is open, that means we don't get a response from the target or from that particular port. All right, and again, it gives you the reason summary here: 977 resets. Right, which means if there are 977 resets, that means that those ports are all those ports are all closed. So if we try this on let's see, on the Windows box, which is Metasploitable 3, and I run this, you'll see exactly what I'm talking about. So there we are. You can see it tells us that the host is up, but all 1000 scan ports on the IP for the Windows virtual machine are all closed, which is not true, because if I run a fast scan 168.1.38 on this, you can see that indeed we have the ports currently open. And remember, there isn't a firewall yet. We haven't talked about evading Windows firewall and bypassing Windows firewalls when performing scans yet. So you can see that it's essentially ineffective against Windows operating systems. So that's all that I wanted to cover in this video, and I'll be seeing you in the next video. Hello everyone, welcome to this video. In this video, we're going to be taking a look at WebMap. WebMap is a web dashboard for Nmap XML reports. Now, in addition to that, it also allows you to perform your own scans, and one of the most important features is the ability to generate really concise and beautiful PDF reports that you can use in your penetration tests. Now, as I said, the great thing about WebMap is the ability to view all your previous scans that have been stored in XML format, and the ability to run your own new scans, and with the additional functionality of being able to schedule scans, etc., etc. So this is a system or a dashboard that I really just need to demonstrate or show you so that you can get the full picture of, right? So the GitHub repository will be added as a resource to this video, and you can also get the Docker Hub link. Again, it'll also be added as a resource to this video. So I'm just going to take you through how to set this up. We're going to be setting this up through Docker. Now, if you're not familiar with Docker, we're going to leave a video in the description section or the resources section of this video to explain exactly what Docker is and how to use it. But very simply, Docker is a containerization platform that allows you to, again, run web apps in containerized formats. And again, because of that, we're able to get the Docker image here, or the actual image that allows us to create as many containers as we want. So an image is sort of like an ISO and then your container is like a very simple VM. And the great thing about Docker is that you can run web applications or deploy them immediately with one click. So the first thing you want to do, I'm running this on a VPS. You can see I'm currently logged into it via SSH. The first thing you want to do is make sure you have Docker installed, and we can do that by typing in apt install docker.io, right? And that's going to install Docker. I already have it installed, so it's not going to overwrite it. If there was an update, it would have updated it. The second thing we need to do is we need to enable the Docker service. So I'm going to say system control enable Docker, and that's going to ensure that the Docker service will run on startup, and then I can then start the service here. So start Docker, and I can then list out information like the images that I have and the various processes that I have, or the running containers that I have. So if I use Docker PSA, that will list all the various containers that I have running. And in this case, you can see I have 0. So once you do that, you really don't need to understand what's going on. Although, as I said, we have a video covering that. You want to go right down on the GitHub repository to usage, and you want to copy this link or this piece of code right over here in your terminal. And what this is going to do is it's going to run Docker, and it's going to pull the web map image from the Docker hub, and it's going to expose it on port 8000, and it's going to store all your XML reports in the temp web map directory. And again, you can then save your reports within that directory so that they can be loaded up and used by webmap. So we'll just copy this command, and you want to go into your terminal and paste that in there and hit enter. Now I already have the Docker, the webmap image. In your case, it will take a few seconds to a minute to download. So if I say Docker images and hit enter, you can see I have the webmap image. But that the previous command that we run, or the first command that we run, or this set of commands, will start up the Docker container for us. And if I type in Docker PSA, you can see it starts up the Docker container for us. And if we check under the status, it tells us it's up for 19 seconds, and then it gives us the ports that it's exposed on. Now, as I said, I'm currently running this on a virtual private server. So I'm just going to install NetTools here, and I'm just going to check my IP address. This is a public IP address, and I'll say ifconfig like so, and that's going to give me my public IP, which is right over here. And now I can access the webmap dashboard by going into my browser, pasting in the IP. If you're running this on your local computer, you can simply type in localhost or use the loopback address. In my case, it's my public IP, and then I specify the port of 8000 and I hit enter. That is going to start up webmap, and immediately it'll tell you that you need a token to access this. So to generate a new token, you want to run this command within your terminal. So we'll do that right now. I'll just paste that command in and hit enter, and it's going to generate a token for us. So we will copy that token, and we will go into webmap and paste that in there and hit login, and that is going to allow us to log in, and voila, this is webmap. So I'm just going to take you through the interface a little bit, and then I'll cover the essential pieces of functionality. And this is something that you really need to experience on your own, right? So on your dashboard, it currently lists how many XML files you have, how many open ports you have, closed ports, etc. And then right down here, it lists in a table all the XML files that you have, which are essentially your scan results. If you go onto your left, you have your sidebar here. This will show you all Nmap scans. You can then take a look at all the Nmap details. You can then execute your own Nmap scan right over here. So it's very simple. You can view all your previous Nmap scans, and you can start your own Nmap scan. So first of all, let us go into the temp directory, and we go into XML, right? Sorry, we want to go into temp, and we want to go into webmap, not XML. And this is where we would store all our Nmap scans that are in XML format. So let's say I ran a simple Nmap scan here, and this is going to be an aggressive scan. We'll actually run a SYN scan. We'll say this is an aggressive scan, and I'm going to run it on ports 21 to port 443. And we're going to run this on nmap.scanme.org, right? And we're going to output this in XML format, which is very important. And we'll output it as nmap.scanme.org. And I'll hit enter. And it's going to tell us, well, Nmap is not installed. So I'll just hit apt install nmap and that's going to install it. And there we are. This is again because I'm running this on a Ubuntu host. So this is a VPS that I have, and we'll just hit enter now, and that is going to start the scan for us. And again, it's going to output the results in an XML file, and we should be able to see it within the web map dashboard in a few seconds here. So we'll just wait for the scan to complete. All right, so the scan is completed, and if we list the files here, you can see that we have the file, but again, I can just change the name here to nmap.scanme.xml because it does not have the extension. So there we have just renamed it to have the extension XML here. And if we go back to our dashboard and we show all the Nmap scans, you can see that we have one XML file that is loaded, and it essentially just gives us a summary of that particular scan. So it tells us on this particular target we have 2 open ports, and it lists out the file here for us, when the scan was initiated, the amount of hosts, etc. And then when we click on the scan right over here, it now gives us an in-depth overview of all the results that we got, and it sorts it out with graphs and pie charts, of course. And then so again, if we take a look at the top, so we start off with the scan information. It gives us the scan time, the type of scan, whether it was a TCP connect scan, a SYN scan, etc. The protocol, very important. It also lists out the nmap command that we ran, which is fantastic. It then gives us the port status, so it sorts it out based on open, filtered, and closed ports. And then it sorts it out in terms of the ports and services. So again, in relation to one another, you have port 22, port 80. You have the ability to generate a PDF report from your results, and whether or not you performed service version enumeration and operating system enumeration. You can then check for CVEs and exploits, which we'll get to in a second. And again, you have the network view. So again, at the bottom here, you have the summary of the amount of hosts that were up if you scanned an entire network or a subnet. You then have the open ports, closed ports, etc. At the bottom, you have the services and their ports. And again, this is sorted in relation to one another. And then at the bottom, again, you get the IP address or the host or the host name of your target. And again, it lists out the services. So when you talk about PDF reports, this is one of the great features of it. So if I click on PDF report, it's going to say generating PDF report. And we want to give this a few seconds to generate. So again, we'll just wait for this to complete. And the great thing about these PDF reports is they're extremely concise and accurate. And as you'll see, they can be used in penetration tests or when writing your penetration testing reports. So you can see it gives you a port scan report, and it gives you the host name or the name of the file rather. And in this case, it gives us the arguments that were provided, when the scan was initiated, the type of scan, and the Nmap version that was used. And then it gives us a summary of all the ports and services. So the amount of hosts up, the ports and services running, the operating systems detected. And then we go right at the bottom, we have the ports that are running, the port state, the product, of course, and the version. So the service version right over here. So in this case, you can see we have OpenSSH 6.6.1 P1. And then for the web server, or running on port 80, we have Apache HTTPD 2.4.7. At the bottom here, we have the default Nmap scripts that were executed, and that is because we actually ran an aggressive scan. So that involves running the scripts in the default category. And at the bottom, we just get a summary and sort of a watermark here, which is perfectly fine. So again, you can see that the scan results and the PDF report are, is extremely concise, and it's really displayed very well. And it's displayed in a way that, the top level management or the upper echelons of an organization can understand. It's visualized very clearly. So if we go back here, we can also, as I said, check for CVEs and exploits if any of these services is vulnerable to a particular exploit. In this case, we'll just reload it one more time. You can see that none of these services is actually vulnerable to a particular CVE. And then, of course, we have the network view, right? So the network view essentially gives you this very nice, beautiful visualization of, again, the various hosts that are discovered, etc. And again, this will become more apparent when we scan a subnet as opposed to something like a single target. But again, that's something for you to explore. Now let's talk about the second piece of functionality, which is running your own scan. So if we go back to the dashboard here, or we go to all the Nmap scans here, and we click on a new Nmap scan. We can also execute our scans from here. And the great thing is that we can specify the XML file name, the parameters, the target IP or the host name, whether we want to schedule the scan, and the frequency of the scan. So for the file name, we will just say we can run this against a site like, we'll just run it again, nmap.scanme.org. So we'll say nmap.scanme, and we'll say comprehensive, right? So that is going to be the name here, and we'll just say this is XML, and the target IP is going to be nmap.scanme.org, and then we specify the nmap parameters or the scan option. So this is going to be a SYN scan. It's going to be service version. I want to run service version detection here, and we can then run a script, like something like script http enum, just a very simple script here, and we can then run this on ports maybe 21, or we can just run it on port 80, right? Port 80 and port 443 if it exists, and we can then say nmap.scanme.org, right? And we can then schedule it, and we can then schedule it daily, weekly, monthly, etc. However, if I disable the schedule, then we really don't need to specify those options. And I just hit start on my scan, and it's going to say your new Nmap scan is running. And once the scan is complete, it's going to tell us that the scan is complete, and it should be displayed on our dashboard with its appropriate file name, and when it was when the scan was actually executed to begin with. So it gives us the file name, the timestamp, the amount of hosts if there are more than one, and the ports that are open, etc. You get the idea. So again, we can just reload this, and based on the type of scan you run, it will take a few seconds. There we are. It tells us the Nmap scan is done. Reload this page, which we'll do, and that should display the option here. However, I'll just reload it one more time. And there we are. We can see we have the nmap.scanme.comprehensive XML, and in this case we get 2 hosts. And if we just open this up, you can see again we only have 2 ports open. And if we just go right over here at the bottom, because we run a particular again, we can see that 2 ports are open, 2 ports are closed, and the reason it's displaying this contradictory information is because we ran the http enum script, and I should have just run this on port 80. But again, it's very simple to run your own types of scans. If you're running this locally, you can run or execute scans directly. However, given the fact that I'm running this on a virtual private server, I can't scan any VM on my network, or I can't scan my own local network. So that is all that I wanted to cover in regards to WebMap. It is a fantastic tool that allows you to again visualize your scans very clearly. And again, it's extremely great in generating really a concise, accurate, and very useful PDF reports. So you can check this out. Again, all the links will be added as a resource to this particular video. And that's going to be it for this video, and I'll be seeing you in the next video.